Welcome back to our series on probability theory. I'm Mark Ledbetter, and this is the out-of-class exercise 3 solutions in detail. So we're going to start with problem number 2.2-2, and this problem I believe is the same in the 9th edition as it is in the 10th edition, but these problems were taken from the 9th edition. All right, so we have this random variable x, and it has a PMF of the absolute value of x plus 1, quantity squared over 9. And we want to compute the expected value of x, the expected value of x squared, and then this quadratic form. So the easiest way to solve these problems is to, when it's a discrete random variable like this, is to make a table. So I'm going to put x here, f of x here, and then I'm going to put x, f of x, and x squared f of x. Why am I doing this? Because I'm looking at the formulas for the expected value of x, which is the sum of x times f of x. And in this case, from x equals -1 to 1. And then e of x squared is equal to the sum from x equals -1 to 1 of x squared f of x. So those are the quantities that we need. So it's a very short PMF, only 3 values of x. So this should be fairly quick. So we have -1, and so when I plug in -1, I get a +1 plus 1 is 2 squared is 4/9. 0 is going to give me 1/9, and +1 is going to give me another 4/9. And when I add this up, I had best get 9 over 9, or 1, and that's exactly what I end up with. So we do have a PMF here. All right, so now I simply take x times f of x. So here I'm going to have -4/9. This is going to give me 0 and a +4/9. So when I add these up, I get 0. And this is e of x, which is also mu. Now, x squared times f of x, what I'm going to do is I'm going to take the x value and multiply it by this to get this bottom one, because when I take x times x, I get x squared and then times f of x. So a negative will give me a positive. -1 times -4/9 gives me a +4/9. 0 times 0 is still 0, and another 1 times 4/9 gives me another 4/9. This is 8/9. This is e of x squared. And so this quantity is 0. This quantity is 8/9. And then I want e of 3 times x squared minus 2 times x plus 4, which by our properties that we've gone over is equal to 3 times the expected value of x squared minus 2 times the expected value of x plus 4. And this is going to be 3 times 8/9 minus 2 times 0, and then plus 4. And when I can cancel, get 3, that's 8/3 plus 4. And so I end up with 12, 8 plus 12, so 20 over 3. Oops. In this problem, which is 2.2-4, we have an insurance company that sells an automobile policy, and this is a very important fact, that it has a deductible of 1 unit. If you know how insurance works, you pay for a policy, and usually there's some level of deductible, which means that if a loss occurs, you have to pay for that deductible first before the insurance company will pay for their portion above that. Okay. We're going to let capital X be a random variable, and it's going to represent the amount of loss that's suffered by the policy holder, not the company, but the policy holder. And so this PMF is you could call it a step function or a two-part function. So when the loss is 0 units, f of x is equal to 0.9. Okay? And when the loss is 1 through 6 units, the value is c over x. And in order to make this a PMF, we need to find what the constant c is, its value. And that's what it says. It says determine c, and then also determine the expected value and amount that the insurance company must pay. Again, we're going to have to be careful because there is a deductible of 1 unit. If you forget that, you get the completely wrong answer. All right. So let's find the first part, which is the value of this constant c that makes f of x a PMF. So what we have is we have the sum of f of x from x equals 0 to x equals 6 must be equal to 1. Now, I had a professor who really didn't like us putting the 1 to the left. But I'll remind you that this is perfectly valid mathematically because this is an equal sign. And it doesn't matter which side you put what quantity on. They are equal. You can read from left to right or right to left. So this is perfectly valid. And so let's go with this. So when x is equal to 0, f of x is equal to 0.9. Now, so I can then say that this is 0.9 plus, now we start at x equals 1 to 6. And this is c over x, which can be written as c times 1 over x. So this is equal to 0.9 plus c times 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6. Now, we're going to find the least common denominator. You don't have to. And in my class, it's fine if you take 6 times 5 times 4 times 3 times 2 times 1, which is 6 factorial. If you want to use that as your common denominator, you're welcome to, because this is not a college algebra class where I'm testing you on how well you reduce fractions, okay? So this is equal to, remember that 1, this is still 1 over on this side of the equal sign, is equal to 0.9 plus c times, and now it turns out that if I take 2 times 3, and then with 4, there's another 2, and then 5, and then I have 6 when I have 2 times 3. So this is the common denominator. 5 times 2 is 10. 2 times 3 is 6. 6 times 10 is 60. So 60 is our least common denominator. And this makes it, by finding the least common denominator, it keeps the numbers lower. But again, you don't have to do that. As long as you get the right answer, I'm not concerned with the form of the fraction. Just don't go to decimal places and round. I want exact answers, okay? And we should be able to do that at this level. All right, so 1 over 1, that's going to be 60 over 60 plus. So this is going to be 60 divided by 2, so that's going to be 30. And then plus 60 divided by 3 is 20. And then plus 60 divided by 4 is going to be 15. And then 60 divided by 5 is 12. And 60 divided by 6 is 10. And so this is equal to 0.9 plus c times, and I get 147 over 60. So again, I'm going to subtract 0.9 from both sides now, and that leaves me with 0.1 on the other side, which is equal to c times 147 over 60. And this is true if and only if c is equal to 0.1 times 60 over 147, which is 6 over 147. I am perfectly happy with this answer. If you'd like to reduce the fraction, then it does reduce to 2 over 49. And although I would not accept the answer in decimal form, it is nice to know what that is for our own mental satisfaction, and it's approximately 0.041. But again, this would not be an acceptable answer. It needs to be an exact answer. All right. So now we want to find the expected value that the insurance company must pay. This is not the expected value of X, because X starts at 0, and when X is 0, the insurance company obviously doesn't pay for anything. There's no loss as far as due to some event. The 0.9 is probably due to costs of operation or some other factor that we're not told about. So I won't speculate too much. Okay, so we want to find the expected payout of the insurance company. So I'm going to define a new random variable y, which is equal to x minus 1. This is subtracting the deductible. Now, I can solve for x, and this becomes x is equal to y plus 1. And then so we're not going to worry about x equals 0 because the insurance company doesn't pay out. So we're going to start our expectation. So let me write the form of e of y. But now I'm going to express it in terms of x, which I hope doesn't confuse you, but helps you to see what we're doing here. And this is going to be the sum of x minus 1, that's what y is defined as, times f of x from x equals 1 to 6. Okay? So x equals 1 to 6. Now, so this is one way you could do this. But I prefer that we make substitutions and do this correctly. So that's why we're starting from 1 to 6, because at 0, if we plugged in the expected value, we get a negative, and there can't be a negative there. No one's paying the insurance company, and that's what a negative value would be. So this is going to be the sum from y equals, when x is 1, y equals 0. When x is 6, y is going to equal 5. So I just plugged in here for x. So x going from 1 to 6 is the same as y from 0 to 5. And then we'll have y, and then we'll have f of y. Okay? And so y, f of y, is, again, we have to substitute in for x, and x becomes y plus 1. So let's do that. Y equals 0. I have y. And then my PMF here with c is going to be 6 over 147x. So this is c, 6 over 147 times 1 over, but x gets replaced with y plus 1. Now 6 over 147 is a constant, so I can pull it out to the front of the summation. 6 over 147 times the sum of y over y plus 1, y equals 0 to 5. And what happens when y is equal to 0? We get 0 over 1, which is 0. So this is going to be 6 over 147 times 0 plus, now for 1, it's going to be 1/2, and then 2/3, and then 3/4, and then 4/5, and then 5/6. Again, we need a common denominator. It's going to be 60 if we want to use a least common denominator. So we have 6 over 147 times. I've got 60 here, and so this is going to be 30 plus 40 plus 45 plus 48 plus 50. So what I did was I divided 60 by 2 and then multiplied it by 1, or multiply by 1 then divide by 2. I divided first in my head. So 60 divided by 2 is 30 times 1 is 30. 60 divided by 3 is 20 times 2 is 40, etc. And when I add these together, I get 60 here and I get 213. And again, you don't have to reduce the fractions. I'm perfectly happy with 1278 over 8820. That is a fine answer. If you want to reduce this, you can, and it will reduce to 71 over 490. That's a fine answer too. And although I will not accept it, it is nice to know that the decimal equivalent is about 145. Okay, so about a 14.5% or 14. So 14.5% of a unit is the expected payout. Okay, this is in units, whatever the units are, and that is the solution to problem number 2. Gave myself plenty of room there. Now problem number 3 is 2.3-19 in the 9th edition of the book. We're given a moment generating function. We're also told that we're going to take random permutations of the first 6 positive integers, or first 5 positive integers. And so we're going to want the number of integers that are what we call in their natural position. So this is the natural order or position. 1 is first, 2 is second, 3 is third, 4 is fourth, and 5 is fifth. So we want to count how many of these integers are in their natural positions or in the natural order. So that's the random variable x. We want to find mu, and we want to find sigma squared. That's the first thing that we want to do. And then we want to find the probability that 1 or more integers are in their natural order. Okay, 1 or more. That is the same as x is greater than or equal to 1, or 1 is at least, or x is at least 1. So what are the possible values of x? Well, we might think that they are 1, 0. None of them are in the correct order. We just reverse them, and that does that, or not reverse them, but we move 5 around to the first position, and then it's out of position and all the others are out of position. Maybe we could have 1, 2, 3, 4, or 5. But it turns out that we're going to leave it like this. But it turns out that if you have 4 of these in the correct position, the 5th one can't help but be in the correct position. So we cannot have exactly 4. When we have 4 in the right position, the 5th one, it can't float. It has to go to its correct position as well, or its natural position. Okay, but we'll use the values of x equals 0 to 5. So let's find mu, which is the expected value of x. Okay, and this is equal to the derivative of m of t at t equals 0. I don't like to write m prime of 0 because students try to plug in 0 first, and you cannot do that. If you do that, and you take the derivative with respect to t, you get 0 because there's no t left in the equation. So when I take the derivative of each term, the first term ends up being 0 because it's a constant. And the second term, I get the constant 45 over 120, and then the derivative of e to the t is simply e to the t. Now for the second one, I get 20 over 120, but then I have to multiply 2e to the 2t by the chain rule. When I take the derivative of e to the 2t, I have to take the derivative of the exponent as well. And so the derivative of that is simply 2. So knowing that pattern, I'm going to go ahead and shorten this and combine it into one step. So it's going to be 40, 2 times 20 is 40 over 120, e to the 2t. Plus 10 times 3 is 30 over 120, e to the 3t. Plus, you notice there's no 4 here. So we go on to 5, so we end up with 5 over 120 e to the 5t. We plug in t, oops, I keep forgetting that page number is hidden down there, t equals 0. And this means that all of the e's raised to the t'th power are going to 1. 0 times e to the 0 power is 1. All right. So I have 45 over 120 plus 40 over 120 plus 30 over 120 plus 5 over 120. And this equals to 240. Nope, I'm in the wrong one. This equals to 120 over 120, which is equal to 1. Okay? So the expected number of integers that are in their correct position is 1 in the natural order. Okay? So that's 95, 100, 120. Now we want the variance. So to find the variance, we first need the expected value of x squared, which is the second derivative of m with respect to t, taken at t equals 0. So we're going to take the derivative of the first derivative, and we end up with 45 over 120 e to the t plus 80 over 120 e to the 2t plus 3 times 30 is 90 over 120 e to the 3t plus 25 over 120 e to the 5t. And at t equals 0, this reduces to 45 plus 80 plus 90 plus 25 over 120, which is equal to 240 over 120, which is 2. Okay? And that means that sigma squared, which is equal to the expected value of x squared minus mu squared, or e of x quantity squared, is equal to 2 minus mu is 1, so 1 squared, which is again equal to 1. Okay. So now in part B, we want the probability that at least one of these integers are in their natural position. So this is equal to the probability that x is equal to 1 plus the probability x is equal to 2 plus the probability x is equal to 3 plus the probability x is equal to 4 plus the probability x is equal to 5. Or we know that there's only one possible value of x that's less than 1, and that's 0. So we could take this as 1 minus the probability that x is less than 1, which is the complement, which is also 1 minus probability x is equal to 0. Now I'm going to get or obtain the entire PMF so you see how it's done. Remember that the expected value, that the moment generating function is the expected value of e to the tx, which can be written as the expected value of e to the xt, which is going to be the sum of e to the xt times f of x, and in this case from x equals 0 to 5. And we're given, so this is going to be f of 0 plus e to the t f of 1 plus e to the 2t f of 2 plus e to the 3t f of 3 plus e to the 4t f of 4 plus e to the 5t f of 5. And what we do is we compare these terms just like we do for any other polynomial. And we could show that this could be written as in a polynomial type of form, but I won't go into that. So what it means is that each of the terms has to be matched. So our moment generating function is given here. And so the first term has to be f of 0. And since this is e to the 1t, this has to be f of 1. So this is f of 0, and then this is going to be f of 2, because we have the 2 here. And then this will be f of 3, and then we'll see that f of 4 has to be 0 because it's missing. And then this, oops, nope, not what I meant to do. Undo. Okay. So this will be f, or not that. This will be f of 5. Okay. So I can use this to make the PMF. And so it turns out that the PMF, x, f of x, for x equals 0, 1, 2, 3, 4, 5, is simply 44 over 120, 45 over 120, 20 over 120, 10 over 120, 0, and 1 over 120. And if I total this up, I get 120 over 120, which is equal to 1, which is correct. So I want the probability that x is at least 1, and I'm going to use the shortest way of finding that, 1 minus the probability that x is equal to 0, which is 1 minus 44 over 120, which is 76 over 120, which can be reduced to 19 over 30. And I'll accept either of these or any other fraction that is exactly the same. And the decimal that I won't accept is 0.633. Okay, and it repeats, of course. So, but to 3 decimal places, 0.633. All right. So now we go to. I have to open up something that I just closed by accident, hoping it still has it. Oh, not that one. It's this one. There we go. So number 4, in the 10th edition, it's 2.3-3. This problem is not in the 9th edition, but I thought it was a good problem, so I wanted to assign it, so I wrote it out in the assignment here. So I have f of x for x equals 1 through 7. And I want to find the mean, the standard deviation, and the index of skewness. So the easiest way to do this is to make a table. And I'm going to have x f of x, x squared f of x, x cubed f of x. The x cubed f of x is for the index of skewness, which is a third centered moment over sigma cubed. So I'll need e of x cubed here. And so x goes from 1 to 7, so I'm going to try to give myself plenty of room. And then I'll need to total these up. And so I'll just write down f of x from the PMF, plugging in x equals, so 1, that's going to be 2 to the 5th. So that's going to be 32 over 64. And then I have 16 over 64, and then 8 over 64. I'm reducing by power of 2, so that means I'm just dividing by 2 as I go through here. I end up with 4 over 64, and then 2 over 64, and then 1 over 64, and for 7, it's given that it's 1 over 64. Okay? And if we total these up, we get 64 over 64, which is exactly what we need for PMF. Now, I'm going to just take the x here. That's a little messy. Let's see if I can clean that up. So I'm going to take the value of x times f of x for each of these. So I end up with 32 over 64, 32 over 64, 24 over 64, 16 over 64, 10 over 64, 6 over 64, and 7 over 64. And when we add those up, we end up with 127 over 64. And this is equal to e of x, which is also equal to mu. Now, I'm going to take x times f of x. When I do this, I end up with x squared f of x. That's the easiest way to do this. Instead of making another row for x squared and x cubed, I'm just going to multiply 2 rows. The key here is to make sure that you multiply the 2 correct numbers and don't get mixed up. It's easy to get distracted in the middle of a tedious operation like this, so double check yourself. Okay, so I'm going to take 1 times 32/64. That's x times f of x. So that's going to give me, again, 32/64. Now, 2 times 32 is going to give me 64 over 64. 3 times 24 is going to give me 72 over 64. 4 times 16 is 64 over 64. 5 times 10 is 50 over 64. See, so make sure you're using this number, not the 2 over 64, okay? So that's what I'm talking about. So 6 times 6 is 36 over 64, and 7 times 7 is 49 over 64. And this is going to add up to 367 over 64. And this is e of x squared. And finally, to calculate x cubed f of x, I'm going to take x times x squared f of x. And so 1 times 32 is 32 over 64. 2 times 64 is 128 over 64. 3 times 72 is 216 over 64. 4 times 64 is 256 over 64. 5 times 50 is 250 over 64. And then 6 times 36 is 216 over 64. And finally, 7 times 49 is 343 over 64. And we add those up to get 1441 over 64. This is e of x cubed. So now we can easily find our answers. So we want first e of x. And this is the sum of x equals 1 to 7 of x times f of x. Remember that I require you to always write the formula. Even though we used a table, I want you to write the formula so that I know that you know what you're doing. And then we're just going to read this directly from the table, 127 over 64, and this is also mu. Okay. Now we've been asked for sigma squared, which is e of x squared minus mu squared, or if you'd rather, it's a little more to write, you could say e of x quantity squared. And you notice that we're sloppy with the parentheses here for ex. In this context, it can't be anything other than the expected value of x. So e of x squared is 367 over 64 minus mu, which is 127 over 64. But I need to square that. And so what I'm going to do is multiply this by 1, 64 over 64. And when I do that, I get 23,488 over 4096. And then it's minus 127 squared is 16,129 over 4096. They have a common denominator, and this works out to be 7359 over 96. So there's sigma squared. Now, I've been asked for sigma. That's the square root of sigma squared. We know that this is 64 squared in the denominator. So this is simply going to be 64, and then this will be the square root of 7359. All right. So this is I believe we were asked for sigma, not sigma squared. So that's the answer to that. Now, I've also asked you for the index of skewness, and one way we can write that is S sub k of x. And it's equal to E of x minus mu. Let me clean that up. I'm going to write it properly. X minus mu cubed over sigma cubed. And I gave you a shortcut for this numerator. And the shortcut is it's E of x cubed minus 3 mu sigma squared minus mu cubed, and then all over sigma cubed. So I'm going to pull these values from the table. EX cubed is 1441 over 64 minus 3 mu is 127 over 64 times sigma squared, which is 7359 over 4096, minus mu cubed, which is 127 over 64 cubed, all over sigma cubed. Sigma cubed can be written as, I'm going to take sigma here and cube it. So I'm going to end up with 7359 times the square root of 7359, or you can say 7359s to the 3/2, and then 64 cubed. Okay? And I'm going to cancel out the 64 cubed in the bottom fraction, because that's going to be the common denominator in the numerator. Because I have a 64 cubed here. This is also 64 cubed. So what I need to do is multiply this first fraction by 64 squared on the top and bottom. And so this gives me 1441 times 64 squared minus 2,803,779 minus 2,048,383 all over 64 cubed. And then this whole thing, I'm going to invert and multiply the fraction in the denominator, which is going to give me 64 cubed over 7359, square root of 7359. So these cancel. And this gives me, when I subtract all of this out, well, let me write it. I get 5,902,336 minus 2,803,779 minus 2,048,383. All of that times, let's see, I've got 1,050,174. And this is, I can reduce 7359 into 3 times 2453. You don't have to. Square root of 7359. And this gives me, so I can divide the top by 3. And that gives me 350,058 over 2453 square root of 7359. I want to see your work until this step, exact values all the way up to here. And then you can calculate this index of skewness as a number, 1.663539, and it keeps on going. I'm going to round this to 3 decimal places. Most of the time, I guess we would probably round this to 1 or 2. But just to give you a better idea of the actual value, 1.664. So this is above 1. It's positive, above 1. So this is going to be skewed, and I believe it's going to be skewed to the right, a positive skew, yes. So positive skew, so this is going to be skewed to the right. If it were negative, it would be skewed to the left. If it was closer to 0, it would be symmetric. And I'm not as familiar with this particular index of skewness, but if it's the one that I'm thinking about, if it's between -1 and +1, we say it's approximately symmetric, okay? But it depends on what you're doing with this PMF or PDF, if it's a continuous distribution. It depends on what you're trying to do as to how close to 0 it needs to be for it to be considered symmetric. Okay, that does it for this problem set. I hope this was helpful for you. I know these are long videos, but I also hope that you can fast forward to the one that you had an issue with and see how it's done in detail, explained, and I hope this makes your life a little less stressful when it comes time for an in-class exercise. Well, please take care of yourself, stay safe, because we want to see you here next time.